everyone, or afternoon, wherever you are. I'm Noam from Microsoft, and I'm gonna talk a bit about responsiveness metric we built in Excel Online, and basically what we learned, what we gathered from this, and of course, we would like to hear feedback, follow-up questions, if any. So, what we were trying to do is create and the focus of this talk going to be about a metric for responsiveness. So I'm not going to talk too much about responsiveness, but mostly about what kind of metric we can use that will be effective and useful for us. And I'll give the details in a moment. Let's just start with recap what when I talk about responsive, what do I mean? I'm talking about responsive interactions. So like it's was published and already discussed in multiple places. The response time for the user to feel comfortable and responsive UI and smooth interactions, he wants to have the response time to be less than 100 milliseconds. And that's what we talk about when we talk about responsive interaction. And that's a term that will return in this, repeat in this talk a couple of times, so it's important to understand it. So the time from the input until the time we present the frame, that's the response time, and it has to be less than 100 milliseconds. So we using event timing API, and this is, I guess, a short snippet of some illustration of how we're using it for our purpose, and I'll quickly go over it because it's important to later understand the metric. Basically, what this code does is tries to capture slow interactions or unresponsive interactions and label them so that we know exactly what the interaction that we're interested in was. For example, if it was a click on a menu, click somewhere else, keyboard in a certain text box, and so on. So we start by creating a map that we track all the interactions that we be able to detect, that we care about mostly. And then we have helper function here that accepts a DOM event and a string of user interaction. This could be a string or any other structure that may be interested in. And we store the interaction using the timestamp of the event as the key. Okay. Then for the element of the interaction that we care about, for example, here, click event, we can call this function, pass the event, and pass some sort of label of the interaction description or name or tag, whatever you want to call it. Only after we do that, then we execute the code that needs to modify the DOM and or CSS and update the UI to respond to the user. After that, we use performance observer, which tracks slow interactions over 100 milliseconds. And then for each entry, we look up the interaction that we stored earlier using the start time of the performance event timing entry as the key. Since they share, according to the spec, the same timeline, the timestamp and the start time, we can reliably look them up. And if we have an interaction, we can consider that was a slow interaction and send the information to the telemetry and analysis analytics systems for further processing. Okay, so that's the basic code, very simplified version. The real code is actually more evolved than this. And now that we have measurements, the measurement that we have is for each named or tagged interactions, we have whether it was responsive or unresponsive. And we have a couple of requirements to create a metric. A metric is something that is useful for the business, and we want to make sure it's stable, that not randomly changes, and we want to be able to use it for regression detection over time and for A/B testing, regression detection or improvement as well. And at least for us, it was important for us to be able to use it per session. I'm not going to go into what we mean by a session, but we can think about it as a page load until tab close for simplicity. Here's an example of some of the tagged interactions that we track, interactions that related to grid selection in Excel, cell edit interactions like typing inside the grid, various menu buttons, and so on. So we started trying to think what would be a useful metric for us. And as you'll see, we were not successful initially, and I'll show a couple of attempts that we had until what current state we have right now, which we think is much better. Okay, so our first attempt, we started by trying to define what is a responsive session. And for us, it made sense to a session that has a lot of interactive interactions or responsive interactions is considered a responsive session. Of course, we want to make sure that that session has at least one interaction to reduce the number of information that we track. And basically, the metric that we have that we call responsiveness is the total number of responsive sessions that we have to the total number of sessions overall. We can create a percent for it and then start tracking it. So some challenges we encountered while using this metric, it was very noisy. It was kind of fluctuating all over, and we had a hard time to stabilize it. It has a lot of variance. We have a lot of variance in the number of interactions per session. Some session has, I don't know, many, I don't say numbers, but many interactions, and some just a few. And this kind of metric has a bias to sessions with fewer interactions from the math of it. Also, we try to kind of stabilize it by tuning the variables. So we have the percentage of interactions that is considered a responsive session. So it's not trivial to determine what is the right number that would make sense or would be really useful for us. And also, if we try to tweak the number to reduce the bias, try to tweak the minimum number of interactions that we want to consider for a session. Again, that was a non-trivial challenge to address. Our second attempt, we actually said, well, that was too complicated. Let's try the simplest thing that we can think of. Completely get rid of the notion of the session and just count all the interactions that we have in the system and calculate the responsive interactions ratio to the total number of interactions, basically the percent of responsive interactions. And we call that our responsiveness metric. What we did find is that this was better. It was better than the first attempt. However, it wasn't sensitive enough for regression, specifically for A/B testing. And you see here on the right, you see a chart that tried to compare an A/B testing of a change. And you can see that it fluctuates, it go up and down, even though we're certain that this change caused a regression, we know from other measurements. And again, this metric is not a per session metric, so it was harder for us to use in some of the analytics systems that we have. So our current approach is somewhat a combination of, I guess, the other approaches or trying to simplify things. And we started by defining session responsiveness, not decide if a session is responsive, just give a score of session responsiveness, which is the ratio of responsive interactions in the session. So we took the number of responsive interactions and divided by the total number of interactions that we were able to capture. We sum all of them and divide by the total number of sessions, and we get a responsiveness metric. Now, I'm not a statistician, so I can't really fully explain the math, but the mathematical intuition for it is based on the strong law of large numbers, which in essence says, I guess, that the average of average tends to converge if we have a large enough sample. That's basically what I understand from it. And even if we're not fully mapping to the mathematical definition of this law, it's probably close enough, and we saw empirical evidence that this metric works much better than the other approaches we tried. We did notice that it's very stable, very low variance, and it's useful to detect regressions for A/B testing and over time. And on the chart here on the right, you see a comparison of an A/B testing between two features, and we can see that it's very reliable, close, and over time it reliably is able to detect the regression consistently. The bottom line is, I guess, the treatment, and the other upper line is the control group, and it's very reliably showing the regression. And we're in the process of adopting it as our main metric for responsiveness across the app. Just another example to show that the average session responsiveness is much more useful for detecting regression. So in this chart, we can see that the blue line represents the metric I explained in slide as number 2, percent of responsive interaction. We can see that it's trending over time, and the bottom is the current approach that we use. It's trending over time, and you can see in general it follows the other metric, the previous metric of percent of responsive interaction. But if there is a regression, even a small one, we can see a big dip because it radically changes the score per session, and it can reliably detect it. So we found it very useful for our purposes. So that's it. We find this type of metric very useful for us, and we're still exploring, investigating other ideas, and also taking a look at the INP publications and trying to gather ideas from there and see if there any way we could improve. And that's all I had. If anyone has follow-up questions or feedback, would be great.
So I'm stopping the recording and we